AIA New York State's live webinar series, Reimagining Digital Transformation for the Architecture Profession. My name is Tannia Chavez, and I will be your moderator for today's program. This session will run for approximately 1.5 hours, with time for questions and answers at the end. This presentation is protected by U.S. and international copyright law. Reproduction, distribution, displays, and use of the presentation without written permission of the speaker is prohibited. This program is registered with the AIA CES for continuing professional education. As such, it does not include content that may be deemed or construed to constitute approval or any method, product, service, enterprise sponsorship, or endorsement by AIA New York State. The statements expressed by speakers, panelists, and other participants reflect their own views and not necessarily reflect the views or positions of AIA or AIA New York, local components, or those of their respective officers, directors, members, employers, or any other organization associated with them and involved in the planning and production of this program. Questions related to the specific products and services may be only addressed at the conclusion of the presentation. This webinar and associated materials are being provided for general education purposes only. Information provided during this webinar and in the materials should not be construed as a professional advice. Participants should consult with a licensed architect or other appropriate professional concerning the subject matter of this webinar. The materials and their application to any specific facts or circumstances, the statements of the webinar, moderator, or panelists are their own and not statements of AIA New York State. Learning objectives. Explain the capabilities and benefits of each software. Discuss the importance of leading-edge technological developments. Explain best practices for implementing new software tools. Discuss how digital technology is related to the built environment. At this time, it is my pleasure to introduce our speakers for today's webinar. Alexander Loyer Hughes, AIA of KURV Architecture, Zoltan Toth, AIA International Associate AIF of Graphisoft, Alejandra Rojas and Matt Sokol of DesignMorphine, Ben Guler for EvolveLAB, and Scott Davidson for Robert McNeil, Rhino, and Grasshopper. And let's welcome Alexander.
Thank you, Tannia. It's a pleasure to be here. I'm going to try to go through this as quickly as possible. So just a background on us, we started KURV Architecture as an architectural service firm. We use a lot of different software to get from A to B. We're going to try to show a project case study real quick. We're going to start with Python programming. We're going to look at Maya, Rhino, and Grasshopper, how we get that into a BIM environment, which is ArchiCAD, and how to get that out to rendering methods for visualization. Next, please. So Python programming, next please. This is a programming language that's quite versatile. It works on a lot of different platforms. It works on Mac, it works on PC, it works on Linux. And a lot of different people use it, from geologists, scientists, architects. And so it's become one of my favorites because it's just very versatile. It's also very hard to break. Next, please. And it, you know, with the programs you have today, it helps you along as you're programming. So it's very forgiving if you make mistakes. It's sort of easy to figure out how to correct. So it's a flexible, versatile programming language that's a lot more user-friendly than many others, and you can share with a lot of other other professions in terms of managing data and other things. Next, please. The reason we like it is, even though it could be intimidating, you know, a lot of different softwares run on Python. So next, please. For example, we can use it for Rhino. Rhino has an interface. Rhino is a 3D modeling software. We can basically run any command that you would by hand with Python. But you can also write your own commands and even extend with Python libraries, and you can connect, for example, databases. You can search geographical or zoning data. You can basically extend Python to do almost anything in the scientific mathematic world and use that data for your projects. And so it's very powerful. Next, please. We also use it with Maya, which is our form finding tool. And so the fact that one programming language we can use to write code for both Rhino and Maya made it our choice of preference. There's a lot of other object-oriented programming languages out there, but this one in particular is just very versatile, and it manages objects very well. So lines, circles, points, geometry, things that architects use a lot, language is sort of inherently built for it. Next, please. So you can see this is ArcGIS, and this is a urban map of New York City, and you can program Python to pull zip code, zoning maps, data ownership information. Anything that the city has as public data is at your reach through Python, and you can script and pull data and pull it into your project however you like. So it makes it very versatile because it's not only for architects, not only for people who are using 3D modeling, but it's also connected to the entire scientific mathematic-based community out there. So, you know, you can exchange information with geologists, with many other people. Next, please. We used it back in 2003, 2004, 2005, when I was at Columbia University. We used it to create cellular automata patterns. We use it for form finding experimentation. Next, please. To create complex geometries that would be very hard for us to draw by hand. And so, you know, back in the day, we were very much experimenting with form, and Python gave us the power to go beyond just you know what you can normally do. Next, please. In our personal sort of research in the office, I really like the mathematical aspect of music. And music in itself has relationships between it that are very mathematical. This is a circle of fifths where notes are laid out in fifths. If you go counterclockwise, it's fourths. There's a minor third, there's a major fifth. Western music has been categorized in many mathematical ways. And I don't want to get too far into this, but next, please. This was created by Pythagoras. Next, please. Who is also, you know, all about proportion and mathematics. He was our first, you know, mathematician in the Western world. Next, please. And so he's used sound and proportion as a relationship, which is very interesting to us. Next, please. And that can be scripted into geometry in many different ways if you understand the proportion behind music and its relationship. Next, please. So if you're interested in seeing more of our experiments and how we tie music into experimental form with Python, you can find it on our Instagram. You can see videos and you can listen to the music and the relationship. Basically, the music and the scales and the notes that we're creating are the blueprints for the form that we're generating. They're one and the same. So if you change a note, the whole form changes. And this is very powerful to us because we use it as an experimentation and a form finding tool for every project we do one way or another. Next, please. So now we're going to talk about Maya, Rhino, and Grasshopper. Next, please. So in Rhino, as I showed you, you can go under the hood and you can use Python to extend its functions, which are very powerful. Next, please. But it also has this visual scripting language, which is much more intuitive for architects, which is called Grasshopper, where one of these nodes represents geometry. It could be a circle, a line, a point, and the relationships between circles, points, and lines. And as you create things, you know, you can take a repetitive task and lay it out this way so that the information is being purged in a manner that's visually understandable to you. And you're basically doing the same thing you would do with Python. You're building relationships between geometry and you're using that to define objects in space. Next, please. But the cool thing is the effect in Rhino is much more visual. So as architects, we can evaluate that data visually, and we can use it to create, design and relationships between design. Next, please. And so as these relationships get more complex and more involved, next, please, you can build more and more complex relationships. And I want to point this out. This is a stage that we're doing for a large sanctuary, and the seating is in the middle and in the center. And we'll look at this a little bit more, but basically all the relationships you're seeing here are scripted through Grasshopper. Next, please. So as you add relationships from one node to another, next, please, objects become more complex, and you can build on that and start building entire languages of relationships between objects. Next, please. And the really cool thing is, if you know a little Python, you can write your own nodes in Grasshopper. Next, please. So here, for example, we're putting Python into nodes, and these nodes can manage colors, they can manage layers. So instead of taking entire afternoons to take things by hand and putting them on a layer, you can actually script them so that conditional statements will put things in one box or another. Next, please. And this is how we can control a large amount of data and actually control the output and manage things either on colors or layers or in its form itself. Next, please. And you can see how that spatially can start creating interest and variation in space. Next, please. And so as these get more complex and they get deeper and deeper into this, next, please. You can take something as basic as a circle as a beginning point. Next, please. And through these complex relationships, you can establish, for example, theater seating. So here, we started taking relationships, from the Greeks, from Neufert, from many other different practices, and started realizing how the proportions of a stage and its width and the height of the stage and the seating dimensions, the distance between benches, the height of a bench, the width of the aisles, the perspective angle towards the stage, the space behind the stage, they're all relationships that have been established in architecture that exist already. And if we interpret those with programming language, then we can actually create a tool that allows us to set this up so no matter how many times we have to redraw this, the proportions are already there and it instantly updates and it gives you the intended result. Next, please. And so the beauty is, while you're doing this in Grasshopper and you're doing this in Rhino, in parallel, you can have it exist in BIM. And so this is the BIM representation of the same thing we were looking at. Next, please. And so as this particular script, which generates the seating, the stage, and the relationships of the auditorium that we were looking at, next. When they're in BIM, we can actually visualize what this would look like. And so we did not draw every bench. The bench is actually a line representation, and then we have a profile in the BIM model that says, oh, I'm your seat profile. I have the right height, the right back, the right setting, the right distance between me. And I'm using the information from Grasshopper to tie that together, and that's giving us a result in the BIM model. Next, please. And you can see the profile here was brought in backwards. Right, so that's an easy fix. We flipped it. Next, and the result is that we have this auditorium that works and can be parametrically updated quickly. Next, please. So when the model exists in Rhino, next, please, it actually exists in BIM in ArchiCAD, and they're one and the same. So any change in the script or in Rhino automatically updates the BIM model. Next, please. And as we've seen this before, next, please. Relationships between other parts in the building can be construed from relationships to other parts. And we can have an entire definition for an entire building complex, even a campus, and it's interrelated. Next, please. So this is a project we're working on where the land use attorney realized that the lot line had a street widening and we had to move the building over by 10 feet. And instead of it being a nightmare, in less than a day, we were able to regenerate the entire building and move it over with seating and everything so that the auditorium would fit. And that's very powerful when we can regenerate an entire building parametrically. Next, please.
Thank you, Alexander. We're almost done.
Yeah, so I'm running out of time, but I just wanted to leave it here and say that even down to the patterns on the rain screen paneling are scripted from the original the original music of this community. I'm going to leave it here. We could go on, but we'll leave it to here and to leave more time for everyone else.
Thank you, Alexander. Before we continue, I would like to remind our attendees that we will have 4 words that will need to be submitted at the end of the presentation to Molly. So please keep track of those words that you will see it through the presentation. Zoltan? Oh, the first word is algorithm. Please write it down. Zoltan, let's welcome Zoltan from Graphisoft.
Thank you, Tannia, and thank you, Alex, for the great presentation. So I work for Graphisoft, and our mission is to empower teams to create great architecture. So we always have a preference for calling customers to present for us and represent us. And I tend to call KURV architecture because I'm such a big fan of their work. Next, please. So Graphisoft, just a few words about the company. We started back in the 80s. And this happened in 1984 when Archicad piqued the interest of Apple, and our founder, Gabor Boyar, actually ended up demonstrating Archicad to Steve Jobs in 1984. And Steve Jobs was really blown away by the possibility of running 3D modeling and generating the documentation from the 3D model on a personal computer. So he became a mentor to Gabor, but also opened up all of the Apple stores and his distribution network to Graphisoft. So that was how our company was kickstarted. And that is also why we support both Mac and PC since then. And that is why we have a statue of Steve Jobs in front of our global HQ. And also, I would like to say that Gabor always had a tendency to hire architects for the development of Archicad. So it really is a software application that is for architects, but also by architects. Next one, please. In 2007, we became part of the Nemetschek Group. And the Nemetschek Group is really an umbrella for 16 somewhat independent brands. And we all believe in open, intelligent workflows so that everybody has the most flexibility, and we promote seamless integration of different software applications from different platforms and different companies. Next one, please. So Nemetschek has really become the #2 player in the AECO software space globally. You can see that we are present in 142 countries, and this is for Nemetschek, but it's roughly the same for Graphisoft. So you might be asking right now, why don't we hear about Nemetschek so much? Next one, please. And my answer to that is that you actually have, and you are. But Nemetschek is really a different organizational structure and different approach in that our 16 brands operate kind of like SMBs. They have a lot of independence. And some examples are Bluebeam, or you can look at the screen, DeRofus, Vectorworks, Graphisoft, Cinema 4D, Risa for the structural engineers here. And the main benefit in that, in having these independent brands, is that they can better focus on innovation, but also they can stay closer to their customers. That is really important to us. So Nemetschek is really a collection of 16 boutique software companies that are united by a common mission. Next one, please. And then, like I said, it's really important to us, and Alex's presentation greatly demonstrated this, that we like to play with everybody. So we play really well with our sister companies within the Nemetschek family. A great example is Bluebeam, that we have a great integration with, or Cinema 4D, but also like to play well with everybody else outside of the Nemetschek family. As you could see, Alex's workflow really greatly depends on a deep integration with Grasshopper and Rhino and ArchiCAD and Maya and Twinmotion. So in a sense, we are trying to get away from this concept and mindset of file formats and go more towards intelligent workflows and deep integrations with pretty much anyone. So really, we believe that everybody should be able to use the software that is the best for them. That is our main philosophy. Next one, please. Well, thank you so much. My name is Zoltan Toth. Thank you, Tannia. Thank you to the AIA New York State. This is such a great learning opportunity for all of us. Thank you, all of you who joined us today.
Thank you, Zoltan. Our second word is modeling. Please write it down. And please let's welcome Alejandra, Rojas, and Matt Sokol from DesignMorphine.
Hi, everybody. If we can go to the next slide, I'm going to quickly introduce myself before Matt takes over. So I've been with DesignMorphine for a few years now, while working in parallel in different firms in New York City and London, working in a various range of projects. So we can go to the next one.
Hi, I'm Matt Sokol. I've also been with DesignMorphine for a few years. Here's some work I recently did. And next slide, please. DesignMorphine was originally started by Svetlana Georgievina and Pavlina Varodaki. They want to take all the cool cutting edge stuff that was happening in architecture and introduce it back home to Bulgaria. So the first DesignMorphine workshops took place in Sofia, Bulgaria. And they also assembled a team that would design the interior of orphanages. Next slide, please. Since that time, we have put on more than 60 workshops, next slide, that take place all over the world. DesignMorphine doesn't have necessarily a central headquarters, but instead we have members all over the globe, as well as we travel whenever we need to put on a workshop. Next slide, please. We also like to work with many different partners, as you see here. Next slide. And we cover a wide range of software. We're very interested in being able to use each software for its best capabilities. So finding the right tool for the job. Next slide, please. And DesignMorphine really tries to cover the full scope of the design world. We extend beyond architecture into fields like robotic fabrication, fashion and jewelry design, virtual reality. Next slide, please. These are images from some of our workshops. Next slide, please. This is a video from our dynamic mutations workshop where students were introduced to Maya, Rhino, Grasshopper, and then as well as many different plugins like Weaverbird, Animany, Mesh Plus, Mesh Tools, Mesh Edit, as well as ZBrush and Unreal Engine. Our workshops really try to challenge the students and provide them with an entire pipeline where they're able to go in with a new design and then come out with a finished product. Our workshops also create a sense of community where, you know, oftentimes we'll grab dinner together, we'll explore the cities together, and many of the people that I've met at the workshops are super cool and I'm still in contact with them today. Next slide, please. This is an example of one of the finished products from our dynamic mutations workshop. Next slide, please. This is our computational matters workshop. In this workshop, students perform the structural analysis and physics simulations using Karamba 3D and Kangaroo plugins for Grasshopper, and actually took their kind of concept all the way from the idea to fabrication. Next slide, please. This is another workshop where we went from design all the way through to fabrication. Students learned how to panelize, learned about structural optimization, as well as the best way to arrange materials for the 3D, for the laser cut file. Next slide, please. This was one of our workshops on jewelry design that took place in Vienna. The workshop focused on Grasshopper, as well as many plugins, such as the Pufferfish plugin designed by DesignMorphine's Michael Pryor. We went all the way from the design to the 3D print. We used Mesh Mixer for optimization, KURV 3D for the 3D printing, as well as rendering with KeyShot. Really, this was one of the workshops that kind of tried to go beyond design and also kind of figure out how these designs will work on the human body, what kind of considerations you need in order to have this be cool but also practical. Next slide, please. Our correlated intricacies workshop. At this one, we learned about Rhino, Grasshopper, including Kangaroo, Karamba, Weaverbird, mesh tools, and BoltzGen. This taught about kind of this hierarchical nature of Grasshopper, setting up different relationships, like a part of whole relationships, being able to deconstruct detailed components. Next slide, please. This is a workshop that took place in Sofia, which what the design intent was to create a pedestrian bridge. The workshop utilized Revit in order to create structural components, paneling system, as well as the DynaShape plugin for Dynamo, which was developed by DesignMorphine's Long Nguyen. Through this workshop, the students learned how to create and manipulate parametric families, schedule the populated geometries, interpolate data, and as well as different presentation techniques such as V-Ray for Revit. Next slide, please. This is our robotic fabrication workshop that took place in Paris. Students learned Rhino, Grasshopper, as well as Taco ABB, which was used for programming the robotic arms. So students were able to go from creating their designs in Rhino all the way to actually having the robot manufactured for them. Students also learned about the end effectors for the robotic arm, which is the component that goes to the end of the robotic arm to actually create the physical product. Next slide, please. This was an aerial symmetries workshop, which took place in Barcelona, where students learned how to create and collect data using drones. This was visualizing data with a Pneumoma plugin for Grasshopper. It also dove into evolutionary and computational principles and nature-inspired adaptive systems. Within Grasshopper, students learned the Weaverbird and Cocoon plugins. This workshop also touched on processing as well as actual drone operations, so using Mission Planner, Pix4D, and Drone Deploy in order to actually send the drones out and collect the data. Next slide, please. This was one of our machine learning workshops that took place in Dubai. Students learned how to use machine learning and neural networks in order to direct their design flow. This workshop kind of created a design for an urban district in Dubai by using these machine learning tools in order to optimize the urban planning strategies. The students also learned the OWL plugin, which was developed by DesignMorphine member Mateusz Zawiecki. Next slide, please. We put on a series of visual machine workshops, which taught the students about different rendering techniques. Next slide, please. In addition to actually learning all the kind of technical skills of working with Rhino, V-Ray, and Photoshop, students also learned kind of various shortcuts in order to optimize the design, as well as the artistic kind of components of working with different colors, what colors balance each other properly, how to fade the background in order to bring more attention to the building, and how to balance the scene using different lighting techniques. Next slide, please. This was from our Transcendent Realities workshop, which took place in New York. Students first learned, got an introduction to Maya, and soon incorporated many different plugins into Maya, including the Mesh Mirror Cut, which was developed by DesignMorphine's Michael Pryor. Once after modeling in Maya, this was later exported into Substance Painter. With that program, since virtual reality, one of the major bottlenecks is the amount of computational power that's required in order to create these virtual worlds. So within Substance Painter, the students were taught how to create two versions of their geometry, one of which would be a very kind of the original heavy model from Maya, and then a very low poly model where all the details are actually baked into the texture. So once that model goes into virtual reality, it doesn't take up as much computational power and it's much easier to run on the computers. This program also introduced students to Unity engine, which is one of the major game engines for creating virtual worlds, as well as all the kind of programming that's required in order to run that. And then in the end of the workshop, the students were able to explore their creations in virtual reality. Next slide, please.
Okay, so how can we implement these parametric tools into our design flow? Next, please. And not only talking about parametric buildings, but how we can start using these algorithms to quickly iterate through design options. How can we make the algorithms work for us? So next, please. Next. So next, please. So parametric and generative design is providing us a new way of working through the design process. The thinking behind computational tools is allowing us to iterate through design options, quickly visualize results, and achieve a higher level of complexity. Next, please. For example, how long would it take to model a form like this and then later to modify it? The idea is to set a smart model with parameters that we can start controlling. Next, please. So here we can see a stair script. So we're going to see how by having two input points and then starting to modify those points, the model quickly regenerates. And this model is created using a C# script that has two stair outlines that are lofted together. And these stair outlines are created by the parameters of the stair thread width, the riser height, and then we're going to see the stair height. So you can see how quickly we can start playing with the different parameters. And more so, we can also start playing with the actual shape of the stair. So in a minute here, we're going to see how the script also allows to play with the angle and with the direction of the stair. So the idea is to start having different scripts that can be recycled and can be used in different projects so that you don't have to remodel, but you can tailor it for different projects. Next, please. So this is a different script showing a passageway design composed of individual post beam structures. So if we go to the next one, please. Before we go into the overall design, just wanted to quickly show you the movement of each of these post beam structures. So you can see that we can control the angle and the height. So it's pretty flexible and dynamic. Next, please. So for the overall design, we wanted to achieve a very dynamic and organic movement flow. So the script takes two curves, and there's one parameter that controls how many structures to place along the curve. So it uses mathematical equations like parabolas and sine waves to implement as the overall movement. So next, please. So in other words, the idea was to have a very gradual change between each of the individual structures. So once we're affecting one, we're actually affecting the entire system. Next, please. So here is a little bit of a massing sketch tool, for example, where we see three different towers that are kind of like intertwined with one another, and we can control the overall system of the floor-to-floor height. We can also control the number of floors. And then if we go to the next one, we can start seeing how we can also start controlling the amount of rotation between all three towers. Next, please. And then the good thing about is that everything is kind of like how you manage data. So once you're able to manage the overall system, you can also start managing the different parts. Next, please. So this is a culmination of like a workshop student project just to illustrate some of these things. Next, please. So here we see that we can also start dealing with facades and controlling like mesh porosity. Next, please. So in this, I wanted to show you quickly one of the workflows that we recently presented with our webinar series for the form finding optimized shell. So if we can go to the next one. So in this webinar, we created a workflow between form finding techniques, structural analysis, and optimization. So if we can just click next, yeah, by using Kangaroo, next Caramba, next Galapagos. So we can go to the next one. So Kangaroo is like a live physics engine inside Grasshopper. So it allows us to use form finding techniques. Next, please. And then once we have the model, we can like set the parameters that we want in order to change the design. In this case, the outer radius, the number of supports, and the overall height. And it's all tied up into the Kangaroo model. So next. And then we can run the Caramba plugin that analyzes the structural analysis of like the model. So here what we're using is Galapagos. So it's an optimization component that allows us to minimize the deflection of the structural components by having or by playing with the different cross sections on the beams of the structure and the amount of supports. So next, please.
Thank you, Alejandra.
Yeah, we can just go over those. Thank you.
Thank you, Alejandra and Matt. Please let's welcome Ben.
Hello? Oh, there you go.
Oh, I'm sorry, before Ben, our third word is rendering. Please write it down.
All right, great. It's a great opportunity to be here. I'm with EvolveLAB. So we're a computational design firm. We support clients ranging from architects, engineers, manufacturers, or owners, so on and so forth. And we have a platform agnostic approach to how we deal with software. So a lot of the tools that we build and a lot of things that we do does this kind of rhythm that we've been seeing from all the different presenters of like, we want to use the best tool for the job. So basically we become that glue for our customers and our clients where we identify certain problems, we find solutions, and then we pretty much compose that solution, deliver that. Thank you. So I grew up and playing a lot of video games, and before I joined or started my architectural path, I was baffled by the big chasm and discrepancy of what I was kind of used to in Hollywood and video games and graphic production, game level design, game mechanics, playing multiplayer online games where you have collaborative efforts of teams working together, where you see live feedback from one another, and having to step into AutoCAD. So next slide. And one of the first things that I had to do is kind of start, when I was drawing in AutoCAD, I'd have to, use extend lines and draw the elevation by tracing lines from a floor plan. And immediately, as I started my path in this, in architecture, that was a very big item that was identified, that we are really far behind other industries. And the reason I bring this up is because I think everyone here has identified that big chasm in our industry and how much we're behind other industries, and such a large opportunity that we have to actually build solutions together to propel our industry into the future. Next. So one of those problems is that we've identified is we have quite a few clients that use SketchUp for sketching, and then that they use Revit for BIM management. And there's a data drop chasm where we would see that a lot of people would run in SketchUp and do their designs in there, because SketchUp is much better to use for quick design iterations and sketching a 3D model. And Revit is much better for documentation, actually putting together a construction set of documents. So basically, we've identified that problem, and we've built this product, this tool, that has a one-to-one translation of geometry and data from SketchUp to Revit. And we didn't want just kind of this blob of mass of 3D meshes into Revit. We wanted to make sure that they're parametric. So if you have a surface that you've identified in SketchUp that is a wall, it translates into Revit as an actual wall element that you could manipulate and still behaves as if you were natively to create it in Revit. So this is one of the solutions that we came up with a problem that was identified that really affects our clients, their ability to be able to use the best tool for the job. We are working on a second version of this one, which will actually work closer and similar to the way Rhino Inside works, which is a really wonderful and awesome improvement from McNeil and Associates, which I'm sure we're going to talk about in the future and the next speaker. So next slide. The second tool that I want to touch on is touches on automation. So basically, if you look at a BIM model, you have all the BIM data there, and if you have it all standardized, you could technically do a lot of the down the line automations if you set these rules up, similar to what other speakers were talking about. Like if I change one ellipse, or if I change one curve, everything else down the line, you don't have to manually redraw, because you're creating relationships between objects. You're not drawing things manually. So with this application, what it does is it automates the process of making panels from a BIM model. So we're working with CI Materials, who's an ACM manufacturer, and what their process is they get Revit models from their architects, from the clients, and they rationalize that. They create the division lines where the panels are, and then create all the way from schematic design to actually sending the data to as a DXF file to route in the CNC machine, and then bend the shape back into its form to be shipped and delivered and installed on the building. So for this process, we're actually using Rhino and Rhino Inside plugin for Revit to process all the geometry. So everything that comes from the architect, it actually uses, we have a custom application that sends the data to the Rhino engine. We unfold it, we do all the geometric operations there, and then we send it back into Revit in an adaptive family, actually. So it actually automatically creates an adaptive family with all the correct points based on user input, and places it from Rhino back into Revit. Now, it's a custom application that we're building for this client, so you don't actually ever see Rhino. It's using the Rhino engine, and we have kind of like our own skin and our own interface that interacts with this, that is just minimized to just the buttons and the menus that they need to be able to build from the architectural model, the actual panels and types and sheets and annotations and documentation and all that whole automation from the schematic panel all the way through CNC instructions and dimensioning, annotations, and so on and so forth, sheet generation, view generation, all of that. So this application is helping our client be a lot more efficient with the use of their time, because a lot of the manual operations that they used to do is now automated. Next slide. This is one of the more progressive projects that we're taking on, and we're partnering with, this client came to us and we're partnering with them, the Atlas Group London, they're based in the UK. And we also have additional partners that we're actually working with, but basically it's a very aggressive project where we're trying to use a generative design for the entire process from schematic design all the way to project delivery. So this is for hospital projects and healthcare facilities where they have we're looking at, there's a very specific target of sizes. So we have maybe something about 5 modules, no more than 5 modules, but these projects are really targeted at third world countries where having hiring architects and hiring engineers and getting that process all the way from schematic design through delivery is very costly for these areas and these regions in the world. And so what we're looking at is building this generative design platform that automatically generates all of the content based on user interface. So we're enlisting a lot of different tools that are, best tool for the job. So we're going to be using Forge and BIM, translate to Revit, and all the different platforms that do a really good job at what they do, and enlist those. We're also looking at implementing Rhino and Rhino Insight and some other Rhino Compute, just so that we could use the best tools for the different processes and deliver this monolith of a platform. So these are the 3 platforms or 3 different projects that I wanted to talk about. Next slide, please. But the big points and the takeaways that I would like to touch on is we want to work on what's meaningful, not what's redundant. So the more we could automate and set up those relationships, the more we could spend our time and have time to do the things that make most impact. So limit manual work and rework by setting up those relationships. And then also the other point is to enjoy the tools that you're using, not have something that is you really have to struggle to make it work. You're really enjoying using them, and it expedites that process. Some recommendations for implementing new software: use trials and demos for some of these software if that exists. Have the people that are most kind of interested in progressive technologies in your firms really give them that freedom to explore. And if you do decide to actually move it to a certain project, it's good to, or to a certain platform, it's good to align a project and a team with that and kind of go cold turkey and actually just use that platform for that project and see how that pans out. Next slide. So digital technology and the built environment. So our environment is really the makeup of our collective design. So the design that we put together and we build is pretty much our environment. So the more options we have, the more agile we are with iterations, the more exploration happens. And the more exploration we have, the more solutions we have, the more chances that we could choose the best solution for that problem. So design tools could really inhibit or assist design. And the overarching goal is to really assist that design process and get the best design out there so that our built environment becomes better and improves. So, yep, those are all the things that I wanted to talk about, and I'll leave some more time for the next presenter. Thank you.
Thank you, Ben. And our last panelist, let's welcome Scott Davidson.
Thank you. So I guess it's my responsibility here to try bringing this all together into one. And I thank everybody for the previous presentations. Next slide, please. I think just so people are familiar, McNeil is we create Rhino and Grasshopper, and we've been around for 48 years. Rhino itself's been around for 28 years, but Rhino's been used a lot for a lot of different projects. From jewelry to shoes to cars and to buildings and beyond. And one of the reasons people use Rhino is because when you use it, it's accurate enough to fabricate from, and obviously very, very complex shapes if that's what you want. Next slide, please. Another piece about this that the community is working with is Rhino is a very, very open platform. There's a lot of open source. There's a lot of our file format is publicly available. The tools that we have you can use to create code to automate some things. And so people experiment with genetic algorithms, with robotics, with virtual reality, with Rhino and Grasshopper, and all types of analysis, whether it's structural, cost, or environmental. And we'll look a little bit about this as we move forward. But I want to be really, really clear about it's the participation of all these people, the experts and the students alike, that is the cutting edge here. That that computer technology has become modern to the point where it's very accessible, not just to computer scientists, but to designers. And that's what we're going to look a lot at today, is the confluence of people and technology and how it's starting to drive change in the building industry, essentially from the inside out. So next slide, please. So the reason people started using Rhino in the first place was for digital fabrication. For instance, the Morpheus Hotel here by Zaha that you see on the side here, all the architects, the structural engineers, the facade detailers, and the fabricators all used Rhino because they could transfer that 3D model there accurately enough from one place to another and use digital fabrication techniques in order to get accurate parts and pieces so that as they put it up on the building, it actually worked. It's something that we wouldn't have even tried to do a few years back. Next slide, please. Another example here from Sonata is the ability to take freeform shapes and break them down into pieces and parts that actually can be fabricated. Fabricate them off-site in a very, very accurate way so that as you place them on the building, that you can this can be made. Next slide, please. Another example, this is the Swatch headquarters in Bern, and again, overall shape, breaking it down into pieces. One of the things that I consistently hear from the people that are working on these projects is how few change orders there actually are when they approach this digital fabrication technique. Next slide, please. And just to show that it's not just parts and pieces and that it can be even a little more complex, this is Sagrada Familia, that they're essentially reverse engineering from plaster models because the rest of it got burned. And so a lot of Rhino and Grasshopper here to reconstruct this in an accurate enough way to fabricate from. And what's really interesting, I wouldn't even call this the cutting edge anymore. I wouldn't call digital fabrication really the cutting edge. That's, you know, we've been doing that for years. A lot of people are using it. So let's talk about what is actually changing. Next slide, please. What I would say that this next generation, this next evolution of the digital transformation is computational design. Next slide, please. So Grasshopper, as the group here has shown, is central to a lot of that. And one of the things that we'd like to like to mention is the reason that Grasshopper, next slide please, is so is used so much is that it's accessible. It's accessible to architects. It's accessible to people that don't necessarily aren't programmers themselves. And as an example, I'm from Seattle and we take our coffee very, very seriously. And just as an example to show how Grasshopper might work it has a series of components that you wire together. The components are the functions. It's a functional programming language. The wires there are data that flow from one place to another. So we can take water, coffee, and energy. We can infuse them together and what we end up with is coffee. Next slide, please. And so if you continue to push those together and wire those up, you can create a series of 3D forms. You can take those 3D forms and you can flatten them out. That can help for fabrication. You can send that fabrication to laser cutting, to CNC. And if you, next slide, please. If you take that to the next level, this is a project by MBBJ, you can actually encode this whole stadium and if you change the inputs, the number of leaves can change, the angle of the seats, all the way down to the structural detail, all driven by an automatic process. And I would say that you know, the cutting edge is that spaghetti, that definition that you see there of the Grasshopper definition. Everybody should be to the point where they realize that that's a program, that that's a script, that the organization of those components reflect the organization of the building. And so all these all students, all the experts that are talking today recognize that that is what organizes this piece. And what this has enabled us to do, and enabled the community, more importantly, the people in the community, is that now architects and designers are tool makers. And so they can create tools, and they can create applications, and they can create virtual scripts to help them in their specific project, whatever is important, whatever is driving the design. And all of a sudden now, we're not beholden to applications that work a certain way and we're working around them. In this case, you can actually create your own tools. But it's not just this technology that's made Grasshopper important. Next slide, please. And so here what you have is some other things. So Grasshopper has hundreds of plugins that can do lighting, environmental simulation, structural simulation, lots of unusual components that allow you to set the time and color, very, very graphic. We used to say that architects don't spell very well, and so this graphic layout is something that works very well to lay things out. But the most important thing, by far the most important thing in this new movement, in this new computational movement, is the people, the community that are working on this. The technology's fine and great, but it's these people that are pushing this forward, that are pushing us, but also pushing everybody else forward. And if you go on to the next slide, please. In order to help people kind of along, we have the community itself has developed things like paneling tools to panelize facades. Next slide, please. And we have a physics engine, so you can fold paper, look at inflation, look at of how magnetic forces interact together. Next slide, please. And it's not just physical form, it's also information about the forms as you're designing. So in this case, calculating square footages, for instance, really quickly. Next slide, please. This is a good example where this is a mall in China, done a combination out of Japan, that where they were able to use physics to decide on the form, but at the same time look at how daylighting came through this and look at the structural aspects of the forces all at the same time at design time. So as they are making these changes, they can look at all these things that matter. Next slide, please. And so, or you can go to an urban planning, looking at, in this case, the direct sun, the ambient light exposure for different zoning decisions. Next slide, please. We're going to jump through these fairly quickly. This is a way of looking at a pedestrian corridor and the views that happen along the way. You can see these kind of get beyond the standard tools that we might think of that have been available to architects in the past. Next slide, please. This is looking at the standard sun shadow, but also on a certain aspect of the project. Next slide, please. And so you can look at form and you can drive it and change it. In this case, not only looking at sun, but looking at the views, how much those views cost, how much daylight each segment can get, and then that can be projected in terms of the square footage value of the design at design time as people are trying to make decisions. Next slide, please. And so this is an example of a subway station in New York, where they're trying to decide, if they added an east access, how many more people could get out of the space and into the space safely. In this case, by adding that east exit, 193% more people could get in and out of the station at any one time, based on virtual flow of people and their behaviors, and using Rhino and Grasshopper to do that. Next slide, please. This is an example of doing a tall structure, and what's happening here is, as the design's changing, Rhino and Grasshopper is deciding the unit count floor by floor, and then actually can look at the cost of the revenue that the building could generate at the time that they're designing. And as they change, the makeup of the rooms change, and therefore the revenue can change, and now you can make decisions real time as you go forward. Next slide, please. And so I want to get to this next piece. This is pretty important. You've heard a little bit about this today. So one of the questions from the group here, the panel, was file formats. How many file formats do you support? How compatible you are with other products? And Rhino does 48 different file formats. It reads and writes all of them, and that's a lot. But I have to say that file formats are flawed. File formats are formats that somebody else decided what data comes from one place and goes to another. All file formats have weaknesses, and all file formats have some strengths. But they're a big barrier between getting information from one place to another. And so what we've done with Rhino 7, and this is something that's currently in progress, although we find people are using it, is we've actually figured out how to take Rhino and Grasshopper and embed it inside other applications. So for instance, ArchiCAD and Graphisoft have kindly worked with us on integrating Rhino and Grasshopper with ArchiCAD. Or we can run with Tekla, or we can run Unreal and Unity we're starting to experiment with. And what it allows you to do is this is Rhino and Grasshopper actually running inside the memory space of another application. And so we're breaking down the walls between applications, allowing you to mix and match not only geometry, but the data itself between the applications and bypass file formats altogether. Can we go to the next slide, please? Let's see if this runs. So this is an example of running Rhino and Grasshopper inside Revit's memory space. And so as I can create a Grasshopper definition, and as I, for instance, pick those walls or wall edges with Grasshopper in Revit, then Grasshopper will be able to create roofs real time using the Revit walls. And if I go in and I change the Revit walls, Grasshopper will change the roofs within Revit. So this is actually driving native Revit objects with Grasshopper. No file formats, no translation. We actually are in the objects. We can do this with, and Graphisoft's done a wonderful job. We can do this with Tekla. We can do this with Sophistic. So what I would say is one of the other pieces of cutting edge technology, and this has a lot to do with modern computer techniques, is we can now start to break down what we would traditionally have considered monolithic applications that we have very little communication between. And each designer now can decide what geometry and what data, what BIM data, transfer from one part of the project to another without any interference. And you can wire up your own components even based on phase, for instance. Anyway, this is called Rhino Inside. It's an open source project, and it's something that well, I've already seen with the previous things. So I think to kind of wrap this up, next slide, please. I think to wrap this up, I want to say that the cutting edge is that designers are now creating their own tools. Next slide, please. And these tools are specific to the project, and they are to inform decisions at design time. And so we are able to see that we are now starting to take these different applications and bring them together in the same memory space so they can talk to each other. And one of the questions is, what should you do in order to prepare for this? Well, I would have to say that you really want to find the people in this community that are really pushing this forward. You know, talk to Alex and talk to Ben and talk to Matt and Alejandra. These are the people that are pushing this forward and can help transition your office or your practice toward these. They're the ones that have the experience. And it's this community that has been growing and growing and growing that is so important, far more important than the technology itself. So thank you.
Thank you so much, Ben. I would like to thank all of our panelists because this has been an amazing presentation. But before we continue, I would like you to please write down our last word, which is workflow. Molly will be sending at the end of the presentation a link for the CE card. So please make sure that you fill it out and you send it out by today midnight. So you can receive your 1.5 LUs. Again, back to the panelists, I would like to thank you all. I think you have blown our minds away with all this presentation. You have all been great. And I would like to remind our attendees that, as you can see, this conversation has to continue. So we'll be having a part 2 on July 14th. So please sign up. And if you would like to have more information, or if you would like us to get an individual webinar with one of the panelists, please email Molly. And for our questions, to begin our QA, I would like to start with Alejandra. And please jump in as you can reply to this. How do innovative design technologies interface with construction practices and or materials, including carbon neutral?
So, sorry, can you repeat the question? I was trying to figure out how to unmute myself again.
How do innovative design technologies interface with construction practices and or materials, including carbon neutral?
Okay, so I think there are, I can give like right away an example. So Michael Pryor, he's one of like the creative directors for DesignMorphine. He was working on the Theater Alliance for Trajan Architects. So that's where he decided to develop the pufferfish plugin so that he could start tweening and doing like more complex surfaces that were somewhat inspired by the work and artist that Scott showed in one of his slides, Matthias Pleasing. I'm still not sure how to pronounce his last name properly. But the good thing is that they work with a fabrication company that told them that they would only work with them by interchanging the actual 3D model. So that allowed them to have full control of what they could and couldn't do. So they went actually into the theater, the construction company, they scanned everything, you know, so that they could like get an accurate 3D representation of the actual space. And then they started collaborating back and forth with the design team saying, hey, here, the curvature that you have modeled is actually not, you know, 100% correct. So we need to like reduce it, or we need to enlarge it so that what you want, you know, for your design can be actually feasible. So that connection to the real world from part of like the constructor, I think it, you know, kind of like emphasize the great thing about these tools and how we can like interface back and forth with the designer and with the fabricator.
Thank you, Alejandra. Ben?
Sorry, what was that?
Can you help us with this question? How do innovative design technologies interface with construction practices and or materials, including carbon neutral?
Yeah, so I think that, and I think I touched on this before a little bit too, is the more you could iterate and the more you could glue together the tools that are really excelling in these domains. So if you want to do solar analysis, or if you want to do energy analysis, and all the more you could establish that relationship in the schematic phase, the more you could actually make decisions that impact carbon neutral design. So if you, for example, if you look at Grasshopper and or if you look at other applications that use evolutionary solvers to figure out a few set of solutions for you. You could set up all the different relationships, allow the algorithm to crunch through a lot of different iterations of what's possible given the constraints that you've identified in the early stages of the process. And once you're presented with those different options, you have the metrics of why you have those as the options. And then you could see the pros and cons of selecting something that's more efficient, but then maybe costs more materials. And you could actually weigh in the pros and cons for all the different metrics that you set up. So I think the way I would answer that is really using technology and creating those relationships early on when the decisions on those different aspects will actually impact the project, and you don't find out about that aspect of the project later on when you can't really change things. It's too late to make changes to the design since you're so far away in the phases of that project. So I think, yeah, that would be my answer for that.
Thank you, Ben.
May I add a little to the subject, if I may? We're the building I was showing is affordable housing, and it's a passive house. And so for us, it's important to make sure that we get everything in terms of affordability correct. And I think for me, the big paradigm is that before I would do a drawing, send it to a few contractors, and they would come back to me with proposals, and they would tell the client, oh, this architect's too expensive, or this is, outside of your budget, or I don't know how I'm gonna do that, right? And now what happens is I give them a schedule of exactly how much rain screen panel is per surface area. I can tell them how many are looking north, how many are looking south, what needs a membrane, what needs a waterproofing, what's 1 hour fire rated. The BIM model gives me all that data. So now I control all the takeoffs, and I can keep the contractors honest. So when a contractor says, well, I need 20,000 square foot of material, and I'm like, well, what's your overage? Oh, we're calculating 10%. I'm like, but the BIM model is telling me I have 5,000. So are you marking it up or what? And so controlling that information, which traditionally is something we never took responsibility for, because frankly, it's a lot of work to calculate. Now it's instant if you set up a tool that does it. And I'm not placing the orders to buy the material, so it's not me, who's going to be liable for making that purchase. But I can tell an owner, I think that contractor's inflating numbers, or they don't seem to match what we have in the model. That's just one aspect of how affordability can be controlled. And with passive house, when we're looking for carbon neutral, all the numbers that go into balancing an HVAC system, daylighting, making sure that we have insulation where we need it, that can all be quantified with the BIM model as well. And so it makes it super powerful to understand if I have to make an adaptation to close an envelope and have less glass or more glass, I can do it instantly with Grasshopper. So I just wanted to add that.
Thank you. How are you handling user interfaces to avoid overly complex computer coding knowledge? Matt?
All right. About the computer interface, first of all, I think Grasshopper has done a brilliant job of that, where it's really kind of very straightforward to start to pick up and kind of gives an introduction overall into the mindset that further leads to computer programming. So before I actually got into computer programming, I started working with Grasshopper, and it really gave me that foundation where kind of you're able to just start with very simple components and create extremely complex kind of relationships between these parts. So you would have, for example, certain kind of corresponding data sets where either like points which have to be rotated, like 0.1, 0.2, 0.3, rotated by 10 degrees, 20 degrees, 30 degrees, and those data sets start to align with each other. Grasshopper does a very great job of setting that up visually, where you're able to kind of organize the data, maintain it, and see how all these components fit together and be able to zoom out and see the overall hierarchy. There is still certain work which is a little bit more complex if you want to do kind of certain custom custom components or certain geometries, which you need to get into more of this programming knowledge. But really, we have seen software that's kind of come out and really open these tools up to everybody.
Thank you,
I have a
man.
quick comment to that, just very quickly.
Thank
There's also tools like Human UI or Shape Diver, where it actually really remakes that front end or that user interface, so that not every user in the firm actually needs to be the programmer, and not every user needs to be someone who's actually editing those graphs. They might just be the people that are actually affecting the design and just having the sliders and so having a simplified view into the back end, so to speak, of that source code. So there's also tools that really lower the barrier to entry for users that are not as experts in that domain.
Yeah, and to jump very quickly on that, like now you have KPF, INEAD, a lot of NBBJ, they have an actual computational design team that are the ones that, like Ben was saying, actually set up the entire model and then distribute it to like different designers so that they are working with the specific parameters, so that they can like iterate through design faster.
Thank you, Alejandra. Alex, any comments?
Sorry, I was unmuting. For me, I think that it's already been said. I mean, I think McNeil has done an incredible job with Grasshopper. I think the Grasshopper idea comes from MaxSP, Max Live, which is Max for Live, which is, it was in the music industry that someone realized that they could make connections between complex programming concepts. If you know Grasshopper, that's all you need to be able to make parametric things, really, in my opinion. And sure, a programming language like Python or C, C+, or C#, they can be daunting to someone who's not in that world. But just with those two things, you can customize anything you want, and you don't need more than that. And then you're already used to using whatever drafting software you use as an architect. So it's just how far you want to take it. And, in terms of simplifying, I think that McNeil has done a great job, and I'd encourage anyone to look at Grasshopper as a simplification of it.
Okay, we only have 10 more minutes, but for the next question, I would like you to hear a little of all of you. What do you think the architectural practice will be in the future as we are coming into a digital transformation age? Alejandra?
I think it's going to be a lot of like machine learning. So going back a little bit into like this exchange of information between designers, contractors, fabricators, there's also going to be, I believe, the machine learning component in where we're going to start having like libraries or like databases with products. So now, hopefully, like, the model is able to like recognize maybe what is the right or the better glass spec to pick, what is the better roof system to pick, and whatnot that is actually matched from like a larger, database.
I think that also the whole architect's role is going to expand further. We're already getting control of the fabrication process and being able to control the tools for fabrication. I think we'll also, instead of having the architect's role kind of end once construction is completed, our buildings themselves will not be these static objects, but be more living, and the architect's role will continue on through the whole lifespan of the building while people are inhabiting it, and making sure that the building is operating very healthy, that all the systems are operational, as well as incorporating nature more into the building. I also think we need to keep looking at technologies which are emerging. I mean, for example, the elevator radically transformed architecture. I think that new autonomous vehicles are also going to have a huge impact on our urban development. And that's something we need to continue looking into. And also basically our connection with technology. So right now we're so connected with our cell phone, that's only going to drive further into prosthetics and implants and, kind of an augmented reality, which will be completely tied to our built environment.
Thank you, Matt. Scott?
I think that it's an interesting time. I think that what we're seeing is people are, designers are taking control of their tools. They're getting more and more data, more and more information, whether it's carbon neutral or whether it's pricing or whether it's fabrication. And I think what you're going to see is that the expectation and the ability of what the designer and the architect can bring is just going to be kind of one notch higher than what's been previously expected. Previously it was design this and get a drawing out so it can get built, and now what owners are starting to expect is more and more data, more and more information at the time of design, so that both qualitatively and quantitatively, the design's actually more optimized for what the owner wants.
Thank you, Scott. Ben?
Yeah, I agree with what was said before, and what I would add is that the role of the kind of architect being the master builder is kind of shifting back towards the architectural domain. And I don't know if it's even the architect anymore. There might be different actually positions where firms are made up of computer programmers sometimes, and people that have certain wings and certain branches that are actually expediting, customizing those tools. And then things that are redundant, dimensioning, or a lot of different parts of the current work will get automated, and in turn allows for us to actually grow in other domains that we always would have liked to grow, and we don't have the time to because of the limited resources. And I think two big things are to me are really interesting. Is one is that generative design, where it's kind of like this top-down approach where we're putting all these different inputs and like certain lines or certain parts of the drawing that I'm setting up as like my constraints, and then generate thousands of options and pick kind of the best ones. I think that's going to be something that's important. But I also think something that's might be even more important is a co-authoring approach to things, which is a much humbler approach to it, where, let's say, if you look at, for example, Gmail, when you're typing an email and it tries to autocomplete the rest of your sentence, that happening for construction documents, where you're kind of starting something, but then as Alejandra mentioned earlier, machine learning, as you're actually letting the computer autocomplete certain parts, you decide whether that autocompletion is right or not right, which creates a backlog of, okay, I'm learning with you. I'm the computer and I'm working with you together to build this thing. And together, basically, that approach might also be very fruitful, which is a slightly different approach than the generative design one. So I think these technologies are really going to, the big picture is that it's going to offload a lot of more the redundant work that we do, and allow us as architects, and I'm not really there, I'm not in that domain anymore, but I'd like to be in that if these tools were already built. But it would allow architects really to focus on what is really meaningful and what really makes an impact to the design process.
Thank you. Thank you, Ben. Alex?
Sorry, can you refresh me with the question again? I get involved listening, and then I forgot what the actual question was. Sorry.
What do you think the architectural practice will be in the future, as we are coming into a digital transformation age?
I mean, I think you're seeing it now. I think that, as Scott was saying, we're writing our own tools to do repetitive tasks. I mean, when I started in architecture school, we were prohibited from using the computer. It was said by my professors, and these are guys that studied with Frank Lloyd Wright, okay? These were guys that were saying that it killed the human soul and it killed the spirit and it killed creativity, and you had to use the hand, right? And I believe that to a certain extent. You have to know how to think and create. Otherwise, what are you going to go program, right? You can't just program something because of it. But fast forward, what we started realizing is that by getting a grasp on the programming languages behind the software that we were using, we could make our own tools and simplify our life. So I might spend a week programming a script that does something, but if that lays out an amphitheater, once I have it, that amphitheater can be regenerated, and I can go around to clients all over town offering them for a floor plan, because I'm not going to spend 3-4 days revising it entirely and laying out the seats again manually like I would have. I just go and tweak the script, and if they want a 1,200 person theater or an 800 person theater, it's a click of a button. And so that's where I think the future is. And I just think it's here and now.
And since I have you, what advice would you give to the architects and designers that are listening to you today?
Advice? Well, it's
prepare
really
for profession.
For what?
How to prepare to our profession with all this technology?
I think there's two sides to it. I mean, I think that on the one hand, it's good for someone to understand how programming languages work and how software works behind the hood, and to be able to question it and not be limited by the bounds of the platform that's given to you. If all of a sudden you want to do something and you can't do it, there's got to be a better way. And normally the answer to that is the programming language or Grasshopper. So sort of challenge what the software platform is expecting you to do. You know, I think I don't want to bash the software, but I started on AutoCAD when I was 17, and I spent many years on it wondering why I felt that my process wasn't making me happy, you know, and I determined to change that around and do it in a way that worked my personal workflow, and that's what I'm showing here today. So one thing is to question that, and the more you know about a programming language or Grasshopper, I think that the more empowering you'll be to be able to do what you want to do. And I think as an architect, that's important. And the other thing is, it's not just about programming and scripting and doing pretty models. You know, I remember Peter Eisenman said once, you know, being a good architect is not just knowing Maya, right? You knowing how to build, knowing how things are built, what the cost is, what the social aspect of it. The rest of our profession and all the aspects of there have to be tied into the technology. So just to give you an example, the project I was showing you, you know, it has these panels and they're colored and they're multicolored. It's not just a random pattern. That community asked for identity. They have music in their community. It's a African-American Baptist church, and they have a choir. We took their music and scripted it onto the panel system on the wall to give them identity. So yes, it's about the software, but it's about making connections to community and making architecture that's meaningful by using it. Otherwise, it's just a gimmick, right? So I think it's both things. It's knowing your technology, and if you're an architect serving profession, knowing your profession. I think that's what I would take away from.
Thank you, Alex. We're actually out of time, but I would like to invite two of our panelists to please give us an advice on how to prepare to the changes to our profession. Alejandra?
Well, one quick advice is that when you don't know all these tools, it may sound like really scary, because we're now talking about a completely different language that involves like a syntax and involves a lot of numbers and connecting things. And even as Grasshopper being like a great visual coding program, I know that sometimes it sounds daunting. But you don't have to be a computational designer or know programming to understand the thinking of like the potential of the tools. And I think that understanding, you know, what are the potentials of like what do you want to do and how it can be achieved is kind of like the first step to, you know, to move forward.
Thank you, Alejandra. Scott?
I think the big piece of this, and actually we're seeing this in a lot of markets, is learning how to create the tools, learning how to program, learning programming concepts. You know, you don't have to know Python or C# or one of these traditional languages. You know, Grasshopper is a great one. And if you aren't in a position to do that, hire students that are. There's many students. I have many deans that have told me that every single architecture student coming out of school now is a programmer. And actually you could say that about electrical engineers now, and you can say that about a lot of professions. The digital world, the digital transformation demands that the people that are designing know enough about the tools to create their own tools, because they're virtual. And so, you know, the people on this panel are a great example of people that you could learn more from. So
thank you. Can we please close with Ben?
Yep, I just had actually a quick comment on what Scott was saying. So I think that totally agree with everything what everyone else said. I think the motif of computer programming has been mentioned a lot, and that was kind of the answer. But to me, the way I would put it is visual programming. I think that's the lowest barrier for entry into that world for most architects that are not exposed to that yet, beyond the students. So just knowing a visual program. So if you use Revit, let's say, you use that in your producing your documents, give space for people that are interested in that and want to learn that, and allow them that overhead time that's not billable for learning more in Dynamo, and giving them that space, because that investment, actually you get return on investment. So use Dynamo, for example, with Revit. If you have Rhino in your process, allow for Grasshopper. Actually, if you have any other one, allow for Grasshopper, because now Grasshopper could be used for most of the other major softwares. You could use it in ArchiCAD, you could use it in TechLog, you could use that software in so many, because of the Rhino inside. You could use Grasshopper, that programming language, which brings that barrier to entry lower in most of the design software and the authoring software that we use right now in producing construction documents and designing buildings.
Thank you, Ben. Well, I would like to thank you all for joining us today, and a special thank you to each of our presenters. Please open your chat box to receive the link to earn your 1.5 LUs, and be sure to register for part 2 on July 14th. Thank you all so much. You've been amazing. Thank you. Take care.
Thank you.
Thank you. Thank you.
Thank you.
Matt, where did everybody go?
We're here, Scott. You can stay a little bit.
Yeah.
All right, great, thanks.
Yeah, my computer's a little slow here. Come on. Come on.
Hey, I wanted to just see if we can actually continue this on. So we may be able to actually get some sort of a survey out there for the people that attended the webinar, and maybe get you guys back in, maybe on a pair, so this way you can talk more about what you're doing and how you can help the profession as well. So I don't know if any of you actually would want to do that. I think it will be tremendous to have the opportunity to talk at length some of the stuff that this type of softwares are actually doing. Because I know it was a short time, but I think it was good overall to get everybody to let everyone know the capabilities of all of these type of softwares.
Yes, Willie, thank you. I agree. It was too short. It was a too short conversation. We're gonna have to continue with this.
Yeah, you could, a lot of these subjects and all of the, I mean, yeah, it could easily, each one of these could be a whole hour on themselves, and it's very useful information, so.
The rabbit hole goes very deep.
It does. It does.
Yeah, thank you, everyone. It's a great talk.
Yeah, thank you.
Thank
Yeah,
you.
thank you all for your participation. It was wonderful.
All right, guys. Gotta go to a job site now. I'll talk to you guys later. Thank you. Thank you for coming on board. Bye.
You're welcome.
Thank you.
Oh, and by the way, I would ask if you can actually attend the second part. I think it'll be some insights in there with the panelists that would probably maybe can piggyback on what you guys discussed today. All right, so see you guys later.
Thanks.
All right.
Bye.
Yeah.
Yeah, Molly should be sending out the invite for that to you all if you haven't gotten it already. So,
All right. Very cool.
Thank you, Nate.
yeah, thank you all very much. Have a great afternoon.
Oh, thank you.
The on this next one, Tannia, there are a couple people that, I mean, if you're going to focus on machine learning and AI specifically, you know, there's a few experts out there that have done it or tried it or can put a frame around it in terms of where we are currently, because it's it's essentially a big mystery in this industry. So I can help you kind of point those people out to you if you're interested in getting somebody that has some project experience with machine learning and things like that.
Thank you so much, Scott. I appreciate it. I will be contacting you for more. I do believe we already have our set of panels, like it's already complete.
Oh, okay. Well,
yes, but we can still check on some edits, and
okay.
we can check on more information and rely on that to continue with this. Because today I felt like it was a little too short.
Well, yeah.
Molly first. Molly, is there a way to like have a break room?
Yes, we can do breakout rooms.
Yes. Like right now with Nate and Scott, and if any of the panelists are here.
Sure, I can put you in one. Give me 1 sec.
Thank you, Molly.
Uh-oh. Molly's putting us in a room and locking the door.
We got detention.
That's right.
Knew we weren't supposed to throw pencils into the ceiling tiles.
And you know there's going to be one less chair than there is people, so.
When the music stops.
That's right.